Artur, take it away.
Okay, thanks for the introduction, Kuba. So, as you may heard from the previous presentation, the GraphQL is perfect or nearly perfect for the microservices. In today's talk, I will quickly present you how we have approached the microservices problem in a more larger scale project. But first of all, let me introduce myself. My name is Artur, and I'm a lead developer at Mirumee. On my daily basis, I work on one of the commercial projects, which is quite microservice heavy. During the implementation of that project, we have shifted our REST endpoints to be covered with the GraphQL data layer. So about this talk, all the examples are taken from a real-life scenario. The project used 15 plus microservices, which were using classic REST API. Most of the backend's code base is written using Python, and we have both synchronous and asynchronous services in stack. And as Ray mentioned, microservices are not always a good solution. However, in this project, we already had a few of those, and we have dealt with quite a specific use case. So about the application. It's pretty standard e-commerce platform, which has a few different single-page applications on top of them, on top of the various backend API services. So first of all, we have a checkout single-page application, which utilizes the backend to perform the checkout process. So it gathers payment data, customer data, and finally places the order. Later on, we have the storefront application, which handles the product catalog, the search, and the user account pages. And within this application, for example, the caching is quite important use case. And last but not least, we have a back office single page application, which essentially has access to the entire data set of the system and is mostly addressed for the customer service employees. How those applications are connected with the backend. So Roy mentioned that usually you will use some sort of data layer or some sort of backend for frontend. However, once we started that project, it wasn't so easy. So we had services that were connected directly to all the microservices in the backend side. So, for example, the checkout application was using the product service, the shipping order, some notifications, invoicing, users, and tax service. And you may say that it's kind of normal stuff when you are dealing with microservices. However, I don't agree in full with that. With such a use case, when you don't have a special gateway-like service, you need to expose all those services to the outside world, and the single-page application would consume those APIs directly. What would happen when you add the storefront application to the mix? Let's see. When you add the storefront application, it fetches mostly the product service, the shipping service to provide the shipping estimates, and the user service to provide maybe some promotions that are user-specific. How could we now change anything in any of those backend services? Let's say that shipping service would not require a different payload. We would need to change every single page application that is already connected. And we didn't even started to connect the back office admin application. As you may notice, it quickly will evolve to architecture like this. So more or less spaghetti-driven architecture, when every backend service would be called by every frontend application. And given this architecture, introducing any changes in any of the endpoints could potentially require changes in all of the frontend apps. So how our team tried to resolve that problem? First of all, as Roy suggested, we tried to use backend frontend approach. At least we analyzed that idea. So if you are not familiar with that design pattern, backend for frontend means that every frontend application has its own dedicated backend service, which is sort of a data layer for that specific frontend. So in our use case, we would need to introduce an API gateway service for each single page application. That would allow us to shape the data directly for every front-end app. However, it will be quite hard to maintain or refactor because the number of backend services will grow quite rapidly. So we rejected that idea, and we have shifted to a different approach. So since we are on the GraphQL Meetup, we decided to go with the GraphQL-based API gateway. Unfortunately, we didn't have such a cool tooling as Roy mentioned with all those directives and automatic mapping. So we have developed an in-house solution. We introduced yet another microservice to our stack. In this case, it was Python microservice, which was powered by Ariadne GraphQL library, which allowed us to cover all our microservices with one specific API, which was GraphQL API. Overall, now the system felt clean and organized. Every single page application was connected to the GraphQL data layer, and the GraphQL data layer was dealing with all those specific calls to backend services. So before we have this, and after the introduction of the GraphQL layer, it felt like this. So much better. However, let's proceed to the details. How the GraphQL API gateway is developed in our case. So as I mentioned, we used Ariadne GraphQL library to power our GraphQL server. To make it asynchronous, we used Starlet as an ASGI server, which those components play pretty nicely with each other, and the API is pretty robust. As we used the GraphQL library of Ariadne, we needed to be schema first. So before we deployed that service, we needed to describe our API with GraphQL schema definition language, which acted like a contract between our front-end apps and backend apps. So, moreover, what are the overall benefits of that shift? As I mentioned, the GraphQL schema acts like an API contract. So the front-end developers are taking active part in the API design process because they know which data they need and which operations they need to perform on those data. Also, thanks to the GraphQL schema, which is static, we, as a backend developers, can easily manage the deprecations of certain fields using the built-in deprecated directive. Also, as a bonus for the front-end developers, the integration with TypeScript is awesome in the GraphQL world. So once we have that schema established, the front-end developers could start their work as soon as the schema is deployed. They don't even need the fully working API. Additionally, all the backend services could remain hidden in the secure network. They don't even need to be exposed because the GraphQL facade is the only key point that is exposed. And that obviously increases the security. Moreover, the backend APIs could be easily refactored because until we keep the contract stable, so we don't mess up with the schema, we can safely refactor the services move the data around, merge them, or even create new ones. Because the front-end applications don't care when the data is stored. The products could live in the product service, in the Elasticsearch, or anywhere you want. It doesn't matter. Also, it's quite easy to connect the new single-page applications or reshape your data, because you have that schema that describes your API, and once you want, for example, create a mobile application, you, as a developer, can see which data is available and what do you want to do with that. There is almost no effort on the backend side when you want to create a new application. New clients just use the data as they need to display it. Also, there is also automatically generated schema documentation, which can be introspected. So the developers could be pretty happy about that. However, there are also some issues and difficulties along with that list of benefits that I already mentioned. What are those issues? First of all, as everything in computer science, naming is hard. In our use case, we don't have federations as in Roy's scenario. So we have only one shared namespace. So we needed to think twice: what is an order or what is a product? Especially when we had, a client-facing application or the customer-facing application versus the admin layer. And both of those applications were connected to the same API gateway. So naming should be really considered. Also, the error handling is quite tricky because you have distributed systems, and you need to be mindful about the error handling. So as I asked the question to the previous talk, we need to prepare on the backend how to deal with the outages that could happen, because in the distributed system, outages are quite natural. So also the front-end applications should be prepared for random null values when that outage situation happens. And the last but not least issue with that approach that we have taken is that extra effort that is needed to expose the public API. Because in our case, we have to keep the REST interfaces of the microservices, because the services sometimes are communicating with each other using a standard HTTP. However, the GraphQL is used for the client-facing applications, and that GraphQL is exposed by the API gateway. So sometimes we need to create the same API twice. However, this is not that bad in the end, because once you establish proper tooling or a proper internal utilities that connects REST endpoints to the GraphQL ones, it's pretty straightforward. And in our case, this is just a trade-off which we have chosen to follow. Yeah, so I believe that's all. I phrased the lightning talk time limit. So thank you all. Do you have any questions?
Thanks, Artur, for sharing your experience. I can definitely confirm the advantages it comes with on the front end firsthand, because actually me and Artur were working on the very same project that was showcased during the presentation today. So yeah, maybe let's jump into some questions. Do we have any? Okay, looks like no questions. So thanks again, Artur.
Thank you.